Just before I do get underway, I'd like to extend the acknowledgement to country this morning, and just also pay my respects to the traditional peoples of the land, including the Wurundjeri, who are the traditional owners of the lands where I come from, out in central west New South Wales. Let me just make sure that's good. There we go. Also, big round of applause to the organisers, because it takes a lot of effort to put in this. Woo! It's a lot of planning, a lot of work, and they're always looking for volunteers. So please, if you want to get involved, hit one of them up, because it's really important to keep these events going. And just a side note, this is my first event in 3 years, like probably many of you. So yeah, thank you again to the organisers just for helping put that on and make this possible. That's about it. I'm all done. No, I do have a disclaimer before I get underway. So I do like tech jokes, and I have a whole bunch of them. And I always love sharing them because, well, it's important that we keep smiling, particularly in current times, but just in general. This is open source, so please share it around. Also add to it if you want as well. But how do fallen trees check for errors? Oh, why, via log files, of course. Oh, my clicker's not working. There we go. Via log files. That was amazing. I think my batteries are dying on this thing. Anyway, sure, it's fine. No, it's definitely dying. There we go. Anyway, so hello, my name is DeveloperSteve. I'm one of the senior developer advocates at a company called Lamigo. But I've been fortunate enough to do talks and presentations all over the world and geek out with so many different amazing communities like yourself. And today's no exception, so please reach out on social media if you're on there, or even just come up and say hi. I'm the one in the grey mask, usually floating around taking photos, usually 360s. So if you want to be in one, come say hi. Would love to chat. In the time before, I'd spent like a lot of time flying around all over the world. That was in the before times. I did my 100th talk in 2016, just to give you an idea, and I sort of stopped counting after that. But I still managed to keep connect to everyone, which is really, really cool. But in the current times, kind of gave us a time to reflect and do a bit of a reset. So now I live out, like I said, in central west New South Wales, where there's lots of green open. Not only is there lots of green open spaces, but we also get to grow our own food, which has like been amazingly cool, because it's like a lot different to what you can get at a supermarket, and you actually don't need a whole lot of space to be able to do that in. But I got a thing in a minute for talking about that. What's really blown my mind is I now own livestock. So I own horses, which is weird because I don't ride them. But they're really nice horses. My wife does. So that's Captain Dan and Astro Boy. They're ex-racehorses that we rescued, and they're amazing. But also, and I might even get a little bit of an R for this one, I'm going to introduce you to one of my personal favorites, Lambda the Lamb. Hopefully that just came up. Oh, it didn't. There we go. Now it came up. Lambda the Lamb, everyone. Now, it's important to note here that in the country, and it's my first time being out there. Like, I've grown up predominantly in the city, so it's been a lot of learnings, but anything with a name is not food. Just going to emphasize that now. So Lambda the Lamb is safe. The pickles, however, and all the other fresh produce we grow, they don't have any names at all, so just saying. But one thing that I've really loved, sort of being out in country places, is being able to combine my geeky tech side with like growing food and being able to, basically live sustainably in a really fun way. So an example of that is a project we did over the holiday break, building out. We've never built hydroponics before, so this was a lot of learning. That's 12 meters of growability. Is that a word? It is now. In a 5-meter space, and it's all off-grid, like it's solar-powered and it has a battery and runs on its own, and it's actually really super water efficient. But alongside sort of building that stuff out, I've been able to use my IoT geekiness, fun, tinkery, makery side to be able to add sensors and do all sorts of fun things with measuring the water temperature and the EC and some really cool stuff inside the water itself where all this food is growing. Because you really need to do that with, particularly hydroponics, to make sure it's got all the nutrients it needs and everything stays alive, and it actually grows really, really quick. And, this is one of the things I really love the most because I love IoT stuff. You may have noticed. I've got a little bit of it sitting over here, which hopefully... Oh, it's actually connected. That's even better. Did it all on its own. We'll get to that. But yeah, IoT things has been, like, incorporating it into my everyday life has kind of been really fun because, well, it helps make things easier and being able to measure, like, what's going into your food, but also just things around you. Another example is I actually built it into my wedding cake, and thankfully it worked and didn't catch fire, which happened one time at an event. My t-shirt caught fire, but that's a story for another completely different day. But what I love the most is then being able to reuse that particular code or that project and being able to adapt it to something completely different, like the wedding cake code actually got used in our coffee table as well, which was kind of fun. Actually, I do have a couple boards to give away, so come up and see me after and I can chuck a few of those out. Actually, the boards that I've used on both those projects are the one that I've used today as well, and with some of the hydroponic gear as well. More recently, and this is a talk for another time, I found all these fun wires and sensors kicking around inside our house, which is, yeah, we'll cover that one next time, because that was some fun right there. No fire yet, which is great, because, well, we don't want that. Anyway, where I'm going with this is last year for reInvent, the team at Lamigo, on the right slide? Yes. The team at Lamigo was trying, that we had a booth there, and it was like they were trying to work out what to do on the booth and how to, like, what engaging fun thing we can do. So for those that don't know what Lamigo does, we do distributed tracing. So we can take your serverless app, for example, and trace all those different microservices inside AWS and be able to map it and do some really nice transactional maps for your invocations, which is cool for being able to trace and debug not only IoT things, but, well, anything really. So, using my IoT geeky powers, I was able to take 2 + 2 + IoT, because, I mean, everything can get IoT in it, and I came up with building this TraceWire game, which actually, for some reason, when I was thinking about putting together this presentation, I thought, I realized that it went from being a TraceWire game to a Buzzwire game, but same. It's essentially the same, having that little wire maze. You know when you were a kid, you had that little wire maze game where you'd work around the maze without setting off the alarm in the quickest time possible? It was basically building one of those. But I never built one of those before in my life. So I thought, this could be fun. Probably one of the biggest challenges was I wasn't going to Vegas to be on the ground, because I tend not to travel too much these days to keep my footprint down, my carbon footprint down. So I had to be able to not only produce this particular game in no time at all, but I had to build it in a way that it could be supported without me being there, and I have to support it remotely. So doing a bit of scoping on what I was going to need to do, I kind of had a fair idea on, like, how it worked and ran some tests, and it seemed pretty, like, straightforward enough. But being able to sort of build stuff out and figure out, where's my clicker? It's not clickering. Oh, there we go. Oh, it's going to skip. There we go. So being able to scope and build out, like, or sort of figure out a list of what I'm going to need to build or what I'm going to need to source to get this thing running was literally the first challenge, as it is with any project. So, I mean, first thing was a board, and I had a few of those kicking around. Actually, I have a lot of them. Being a maker, like, I've always got boxes of cables and little boards and things kicking around. Incidentally, if there's any makers in the audience, oh, there's one. Everyone's putting their hands up. It's great. Anyway, makers are typically known to hoard every electrical thing known to, like, possible that you could possibly get. A good example of this is the wire that I ended up using for the top of this trace wire, and I've got a camera set up where you can see the camera, so we can, when I do the demo, you'll be able to see it. But the copper wire I actually harvested from some old TV coax that, well, no one really uses anymore, but it's great for building Buzzwire games. So if you have some of that lying around, you may need it one day. It was in a massive box of cables, and I needed that one day, so it saved the day. On top of that, oh, I think it's going out of range. That's what the problem is. Where am I up to? Oh, there we go. On top of that, I needed to prototype a 3D print, because they needed a case for this thing to sit in so that it kind of looked on brand. And I have a few 3D printers, but the one in particular I used had a dual nozzle, so I can do, like, 2 colors at the 3D print, 2 nozzles, 2 colors at the same time, which is tricky. Actually, it's really tricky to do, because you've got to make sure 2 of them are lined up at the same time as opposed to 1 nozzle. Any people do 3D printing? Everyone's putting their hand up. It's amazing. Anyway, with 3D printing, you have to make sure the nozzles are all lined up, and it's a bit fiddly. Fun fact, too, you can actually, I'm using PowerPoint, and you can actually take your STL file from your 3D print renders concepts and drop them into PowerPoint and animate them. It's kind of fun, because you can do that. Anyway, I just wanted to do that, because I haven't done a presentation in a while, and 3D prints. On top of that, I also needed to obviously handle some type of contact from the actual device itself, which is what we're going to be looking at today, and send that through to somewhere. Of course, AWS IoT, pretty easy to use, pretty easy to set up. We'll talk about that one in a moment. Database to store everything in, because I'm going to record time from the device, so the time it takes to either trigger the wire or finish the maze, and then send that through to somewhere, process it, and store it in a database. What's more is I kind of decided, I mean, everyone's familiar with Murphy's Law. I thought, IoT thing, live conference, I probably want to build 3 of them. One of them's to stay with me. This is my prototype device. And then another 2 to go over, just in case something goes wrong. So I literally built 3 of these in one go, all in the space of like no time at all. But we'll get into that. Where to begin? Let's start with the board. So I'm not going to go too much into this one. See what I did there? Let's get a little board. So the board itself, I used a ESP32D, for those that are familiar with little IoT board things. These are really super cheap, and they've got Wi-Fi, which is kind of all I needed. I had a bag of these left over from past adventures, so I thought, perfect thing to use. What can go wrong? It should be fairly easy. On the architecture side of things, I decided to, well, pretty straightforward really. I had the TraceWire game going into the IoT, or connecting into IoT, putting in an SQS putting a message in, and the message itself, fairly basic, like all I needed was time itself and, well, maybe some type of reference ID, but the device was literally just going to send through time. We'd record that, send it into a few different places, like a leaderboard, which we could display onto a booth screen, and then interact with that and add things like email address to make sure we know who we were talking to when we wanted to give away prizes, etc. Like, fairly easy setup. I thought this should be easy, right? I've got a couple months, like this was October from memory. It's a bit of a blur, but I think it was about October. Like, reInvent wasn't going to happen until like November. I got loads and loads of time. And usually when you start to think that, you start to think, yeah, here's where things get interesting. And whenever we're building out like any project, let alone IoT things, there's always little dragons that sort of pop their head up along the way, and you have to do a lot of pivots really quickly, particularly when you're working with like deadlines. For this particular thing, I had to make sure that I not only built 3 of them, but I shipped 2 of them to the US in time from a little country town in the middle of central New South Wales. This was the same time remember when all those floods were happening? Yeah, this is the same time as that. So yeah, that kind of made things a little tricky and interesting. The 3D printing side, I mean, there was a lot of it being done. The main body itself, let me trigger all of them. There we go. The main body itself and then the end caps was kind of troublesome enough. The main body was about 32 centimeters and took about 14 hours to print. Chewed through a lot of solar battery, let me tell you. But alongside that, I was also prototyping on the fly while building the code, so I didn't quite know how the code was going to handle with the server things while I was doing all the printing for this sort of stuff. So there's a lot of iterating backwards and forwards. Literally, and this is my downloads folder. I don't know if you can, yeah, that's my downloads folder. This is all the prototyping from each iteration for each part of that particular model, and that's like everything from the end caps to the main body to all the little colored pieces, like was all of it. And constantly you would print something and then sort of realize that it wasn't going to work or quite sit right, so you have to redo it, you take it back in, re-render it, et cetera, et cetera. It was a lot of backwards and forwardsing. On top of that, you had the problem of like blocked nozzles. For those that do 3D printing things, this is pretty common. Like you're gonna block nozzles up all the time. aside from that, and this is where the fun serverless part begins, is I had to connect into the board itself, or get the board to talk to some type of server thing to record the information from the device itself. So for that, I had this little prototype. There it is. I mean, all fun IoT adventures start with a blinky light, and this was no exception. So you can see here when I push that button, it just sends a simple message through, connects to Wi-Fi, sends a message through to the actual server, and then from there, like, I can do anything I want with it. That's kind of the easy bit. The hard part's getting that connection in. Now, thankfully, AWS IoT, fairly easy to use. You grab your root certificates, you grab your credentials, you load those into an Arduino sketch, load it up, and it's good to go. There's some really good tutorials I have, and it's pretty easy. There's a lot of great demo code and stuff, which is fine until you start to get these funky, like, there's no communications coming through. So I'm checking the logs. I was pulling the internet apart, trying to work out why my board's like that. It was pretty simple. I could spin up my own servers and see like the communications coming through, and it was like super, super easy. Then I remembered that these boards not only are a number of years old now, but also don't support like SSL handshakes like that AWS IoT would preferably want you to have for security reasons. They weren't able to do the initial connection, so I couldn't get any data through, which kind of, skipped a bit. Oh yeah, that's right, I had it automatically come up. Yeah, which made me pull that face because like I was running out of time. Literally a week to go, and like I suddenly discovered that these boards weren't going to work. This is why you don't leave things to the last minute. And I couldn't get new ones really quickly. So what I actually ended up finding out was I needed to get an FTDI, one of these little connectors. It was literally like a $3 piece that I couldn't get in time. So needed to come up with something super, super quick to be able to get a workaround in place, which I ended up doing. But we'll get to that in a sec. I'm also going to mention here the 5 parallel long polling connections with, that Lambda uses when it's doing its SQS queue handling. That also drove me nuts when I actually did get a connection through and was then trying to handle multiple connections from a few different devices. But I'm going to leave that one for another day. So that one's a whole other talk. Whoops. Oh, my clicker is really not happy. See, Murphy's Law attacking. Anyway. What I ended up doing, and this is where sort of serverless came into play, was I cheated. Gasp. So to get around all that, I decided maybe I should just cut out AWS IoT connection altogether and just use a Lambda endpoint publicly available for the device to be able to connect into, which was pretty easy, and I've got the sketch we'll go through in a sec. Just picking up the AWS certificate and then loading that in as part of like a trust connection with the Wi-Fi library I'm using on the Arduino side. So literally all I have to do on the, yes, let's go with that one. All I had to do with the Lambda code was just handle a get variable, and I was able to get time down to milliseconds through to a Lambda script, which I could then do whatever I wanted to. In this case, store it inside a database. On the sketch side, which is kind of where all the logic kind of ended up. So anyone familiar with Arduino? Yes, yay, people putting their hands up. On the Arduino side, so I'm instigating the pins, doing a Wi-Fi connection, of course, which my codes go on the top. And then I'm instigating all the different pins to create the circuit through the actual trace wire itself. And doing some funky stuff with time. I've got my Lambda endpoint in there and the root certificate from AWS just to make sure the device itself can trust that particular endpoint, which kind of made the Wi-Fi library happy. The only other thing I needed was a way to send that data through using like a reusable function. So I have a send data function which basically handles all that for me and sends all that through. Inside the loop, there's essentially 3 different states that this thing goes into. When I'll demo it in a minute. Hopefully it'll work. Hopefully there won't be any fire. No, there won't. I promise there wouldn't be any fire. They do have things on standby, but anyway. Inside this, essentially when I push the button, light goes on, game starts, timer starts, and then either 2 different things are going to happen. Either 2 wires are going to touch, the one wire will touch the actual maze wire, and then game over, send time. Or I needed some way to reset it in case there was like an accidental press. If I push the button a second time, the light goes off. There's an LED on the side, and it does the same thing. It basically sends through whatever time it's got available, which is pretty easy to do. So the reality architecture then became essentially the same thing without the IoT part built in. So it was literally a last-minute pivot. And I managed to ship it 12 days before I actually needed it to be there. And you might be asking, did it make it? Did it arrive in time? It missed it by 1 day. Yeah, those floods, eh? Anyway, I was like refreshing the page, like I probably crashed Australia Post website, like checking to make sure that this thing arrived in time. Anyway, I'm gonna now tempt the proverbial gods of demos and see if we can't get this thing to work. Because I'm also using a mini camera to do it as well. So, why does this not show a displays thingy? Hang on, I'm going to switch back to my displays. There we go. Yeah, this thing is just not fun. Oh, here we go. Mirror. Oh, yes. Okay. Sweet. All right. And it's not working. Isn't that cool? Wait, can I drag that across? Oh, I can drag that across. All right, well, it's not working, but we'll just pivot that. And now I've lost my mouse. Oh, there it is. All right, let me drag that over. Hey, there we go. All right, so I have a little overhead camera here, just to make things a little easier. Oh, there we go. That kind of works. All right, so if I push this button here, you'll see the light go on. Oops, but my hand in the way. No, now I pressed it twice. Oh, see, live demos with IoT things. What can go wrong? I'm pretty sure it's now trying to talk to the server to tell it how much time. Anyway, isn't that a fun demo, the light coming on? Oh. Wait, can I do... All right, so the other way to do this is that's sending through communication things. So I know I'm running out of time. So let's do... Oh yeah, sweet. And I should be able to drag that over. There we go. So this is the Arduino IDE, and you can see here, like it's been sending through information, and it's getting an ID back as well. So let me see if I can make that a bit bigger. So it's kind of working. Well, it's doing what it kind of should. You can see here it's connecting to server, so that's when the two different times are being measured, like now versus then, and the difference. And the difference is what we're interested in. So as part of that, it's connecting to the server, connecting to the Lambda endpoint, the public endpoint, and sending that through, and then getting a response back, which brings back a database ID, which is what that is. So it kind of works. And we can see that also in... Oh, do I get another screen? No, I don't. That's fine. It's really tricky doing this big screening thing. Yeah, there we go. All right, now I should be able to drag that across. And you can see that also in here, because if I refresh that, I should be able to grab one of these IDs and then be able to see the hash reference ID from that entry. There we go there. So that's what it's actually sending through there. It made it. This is how it should be working. Hurrah. Now let's see if I can get my screen to go back. Extended display. Oops. Okay, cool. Almost. Yay, I made it. Whew. How are we going for time? Yeah, okay, cool. I thought so, that's why I was rushing. Kind of almost got the demo to work. Woo! Yay for pivots. Just some takeaways as I wrap up, and thankfully nothing exploded and there's no fire, but it kind of worked, remember to always keep every cable, because you don't know when you're going to use it. Literally that copper cable and a whole bunch more like it was TV coax in a past life. Now it's this. Yeah, make sure you have enough build time and enough postage time, and there's no floods. Please, no floods. On top of that, make sure you monitor, trace everything, like everything you deploy, because like Sarah was saying, you never know when you're going to need it, and it always pays to search for those needles in haystacks every time. If you want to read about this adventure and actually see the code and some videos of it working, check out our blog, check out the Lamigo blog, because I've done a whole bunch of write-ups on it as well, or come up and see me, or check my GitHub. That's kind of me. I think I'm walking out of range. There we go. Please, as we wrap up, please always remember to use your tech superpowers for good, and remember to be excellent to each other. Thank you very much.